Barkanmu da zuwa Mass Hausa TV. And yau, insha Allah, we are going to start our topic of logarithm theorem. This word logarithm, we are going to see how we can generalize the theorem. First of all, we have to remember the meaning of logarithm. The meaning of logarithm. So, going back the definition of indices. If you go back from the definition of indices, suppose you have a number 1 to 5. This 1 to 5 can be expressed as 5 times 5 times 5, which is the same thing as 5 raised to 3. And if 1 to 5 is equals to 5 raised to 3, then we are going to say we are going to say that log 1 to 5 base 5 is the same thing as 3. That is the meaning from the indices. And if you have 2, 4, 3, this is the same thing as 3 times 3 times 3 times 3 times 3, which is equivalent to 3 raised to 5. 3 raised to 5. And if 243 is equals to 3 raised to 5, then log 243 base 3 is the same thing as 5, all from the law of indices. And you see, if you see this 1000, this 1000 is the same thing as 10 times 10 times 10, which is the same thing 10 raised to 3. And if 1000 is equals to 10 raised to 3, then log 1000 base 10 is the same thing as 3. Log 1000 base 10 is the same thing as 3. All this from the law of indices. And in general, if you have y is equals to x raised to the power of a, then we can say that log y base x is equals to a. For example, we evaluate log 25 base 5, 1, 2, log 64 base 4, 3, log 0.5 base 2. So let us see how we can do this. We say that we let the whole log, let's take number 1, let the whole log this log, log 25 base 5 is something as x. Let's take it as this. So if we take this, now we allow this to go here to be the power of this. We allow this, those unknown, to be the power of this. Thus you have 5 raised to x is 25. From then you remember the indices. If you have 5 raised to x, this is something as 5 raised to 2. 5 raised to 2. So by equating the power, we have x equals to 2. if you equate the power, we have x is the same thing as 2. Then when we take the next example, we do the same thing. We let number 2, we let log 64 base 4 to be is equals to y, for example. So we allow this y to come here as a power, which is something as 64. So 64, we take it as power. Then 64, we have 4 raised to power of y is something as 4 raised to, you see, 4 times 4, 16 times 4 raised to 3. Then by equating power, our y is something as 3. Then when we move to this number 3, we also let log 0.5 base 2 is equals to x. If that's the case, we allow the x to come here, that's as power, which is 0. This, when we allow x to come here as power. Then this is the same thing as where you have 2 raised to the power of x. This is equals to 5 over 10, which is the same thing as 1 over 2, which is equals to 2 raised to the power of minus 1. So 2 raised to the power of x is equals to 2 raised to the power of negative. So by equating the index, our x is equals to as negative of 1. Thank you for watching. Don't forget to subscribe our channel on YouTube to get more